is a video response for a question we had regarding Math 3C probability.
So the question is, you flip a coin, and you keep flipping until you get your first heads. But we already know what that sounds like, right? If you're waiting until your first success, that's geometric. So one thing I didn't mention in the review, but I definitely should have, so I'll mention it now, is the expectation for geometric is 1 over p. Okay? The variance for geometric is 1 minus p over p squared. I don't think you'd have to worry too much about this, but you definitely should know this. This also follows common sense. Because think about it. Say you're trying to roll a 6 on a 6-sided die. How many times on average do you think you should have to roll that thing before you end up getting a 6? If you took a random guess 6 times, you would probably get a 6. So let's see if that makes sense. So the expectation is 1 over, what is the probability of getting a 6? It's one option out of 6. So this should be, 6 looks really good. Okay, so at least that part makes sense. Now let's try to do this problem. So if I were doing this, I would literally think, okay, you're flipping a coin. The probability of getting a heads is 1/2, right? If you believe this for the expectation of the geometric variable, you would get 2. And we're done. Okay? However, just in case, if you had to do the long format way, again, I don't think you should worry about it too much, but in one of these problems, it's sort of a brute force way. They wanted you to show by brute force that in this specific case, the answer is 2. So we'll try to do it by brute force. Okay? So let's look at this. Remember, expectation is sum of the score times probability score. Okay, so something like this. Let's look at what the geometric looks like though. So if I'm looking at the geometric, in this specific case, what's it going to look like? Well, you could succeed on the first try, right? If you succeeded on the first try, you would just get a heads. And there's a 1/2 chance you do that, right? Well, the probability is 1/2. Okay, so what about the second time? So what if it took you 2 tries? Well, that means the first time you get a tails and then a heads, right? And you could do the formula or you can see it directly, 1/2 here, 1/2 here. I think the probability is 1/2 squared. Okay. How about this? 1, 2, 3. So again, tails, tails, heads. Then you would end up getting something like 1/2 times 1/2 times 1/2, 1/2 cubed. Okay? You can totally see what this is turning out, how this is turning out, right? So now let's try this. What is the first score you can get? Well, you can get a 1. Okay, it could take you 1 try. What is the probability of it happening on the first try? 1/2, right? What's the second score you can get? Well, the second score you can get looks like it could be a 2. You can succeed on the second try, so that's a 2. What's the probability that it takes you 2 tries? 1/2 squared, right? So 1/2 squared. Okay, so let's take that away. How about the third try? Well, again, you're going to see the pattern, right? It takes you 3 tries. Probability it takes you 3 tries, 1/2 cubed. Okay. Again, keep going, because this will keep going. If you want the expected value, you have to add all of them together. Okay. So that's not so bad. So to try to get this sum to work, let's see what we can do. Let me see if I can simplify this. First, I think there's a 1/2 everywhere, so let's factor it out. So let's factor out that 1/2. What do I have left over? 1 plus 2 times 1/2 plus 3 times 1/2 squared plus ... Okay. Well, that looks a little bit better, but it's still not quite close to getting me a sum. Okay. But I kind of noticed something interesting going on. If you evaluate this, so look at this portion. Doesn't this portion kind of look like this? So whenever you get similarity, you can kind of group things together. Look at this. This is 1/2, 1/2 squared, 1/2 cubed. This is 1/2, 1/2 squared, 1/2 cubed. So everything looks like it's a very similar pattern, right? There's only 2 differences. One, I need to get rid of this 1, but I can do that easily. I can distribute the 1/2 here and then to this whole thing, which I'm going to do. So I'm going to pull out the 1/2. Then I'm going to start on this pattern. But then I have 1/2 times 1, and then 1/2 times this whole thing that's left over. So 2 times 1/2 plus 3 times 1/2 squared plus... Does everybody agree? All I did was I just distributed this 1/2 so I could isolate this term and pull him away. Because this is the part that I think is interesting. This pattern looks like the original pattern. Okay. However, the only difference is this is a 2 and a 3 and a 4, so on. The original pattern started off 1, 2, 3. So it looks like I'm just bumping up. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, etc. Right? Let me think for a second about what's changed. If I did that, I have x times p of x, right? But do you remember what happened? What happened if I took the expectation, I wanted the expectation of 2x plus, I don't know, 6. Something like this. We did this during the review. The idea was it's the score that gets changed, but not the probability, right? So the probability stays the same, but this score is what changes, right? When you're computing an expectation on guys being manipulated, like x getting doubled and then having 6 added to it. So same thing here. This is an expectation. The probabilities seem to be staying the same, right? The only thing that's being manipulated is the score, right? And how is this score different from that one? You've taken the old score and you've added 1. So my claim is this is the expectation of x plus 1. Because it starts with the same, 1/2, the 1/2 squared, 1/2 cubed. The probabilities are the same. But these scores starting at 1 differ because you've added 1 to them, right? So 1 to 2, 2 to 3, 3 to 4, etc. Okay, so all of this is expectation of x plus 1. This factor of 1/2 stays in front. This 1/2 is here. Do you remember what the whole thing was? Now it's just arithmetic. So if I distribute, remember the plus 1. This is a property, remember? So if you add 1 to every score, it's the old average plus 1. So that's where we get this guy. Then over here, I have 1/2. So I get the expectation, where do I have some room? And write it. So the expectation is now 1/2 plus 1/2 of the expectation plus 1. This guy over here. These are just numbers, so we're going to multiply through by 1/2. So 1/2 EX plus 1/2 plus 1/2 is equal to EX, right? I'm going to take 1/2 and 1/2 and add them together. That makes 1. So now I have EX is equal to 1/2 EX plus 1. But you know what this is? This is half an apple and 1 apple. Subtract half an apple from both sides. Once you do that, we're going to have 1/2 EX is equal to 1, right? And then just to finish it off, multiply both sides by 2. EX is equal to 2. Okay. So all of that work to tell you what we could see from 1 over 1/2, which is 2. So not happening.
Guys, bye now. Hope to see you back again soon.